So thank you. Just a very quick introduction. My name is Parth. I'm a partner engineer working very closely with Mark and in supporting EPAM, enabling all the engineers, looking at all the technical workloads that they're delivering for all our customers and assisting them in growing the talent, helping out wherever I can. With that, I'm very impressed. One thing I'll say is I'm very impressed with this organization that you guys have started over here, and I already spoke to Carol saying I will be more than happy to support in any way I can by providing some content to you guys or exposing any new product and services that we introduce through these kind of workshops, whatever we can offer. With that, what I'm going to talk about today is all the different serverless components that we have available. As a developer, I'm sure you do not want to deal with managing infrastructure, setting up servers, networking, all those. You want to purely write code that really makes impact to your customers and drives value and ROI to them, right? So serverless is the next paradigm. It's the new paradigm that a lot of public cloud vendors have just recently onboarded, but at Google, it has been the way we have been doing things for over a decade, but we're now making it available through our cloud platform. So you guys are in a very good spot that you have access to these new technology and you can quickly learn and develop applications that you can launch them on Google Cloud, which was, and it is one of the most developer-friendly cloud you will experience. So with that, what we're going to talk about is what is serverless. I'm sure you all know it, but from how we see serverless, I just wanted to give you that idea, and then talk about serverless for apps, serverless for data. So it's not just the front-end applications that you built, but also what are other serverless back-end systems that we make available to you. And then how we can also provide you a serverless way of doing machine learning and AI using our serverless APIs that we make available to you. And then how do we glue it all together and build out an end-to-end application system, whatever you are trying to work on, right? How do they all come together? And then see some examples, right? So with that, what are the main three principles of serverless? One is invisible infrastructure. I just spoke about that. You don't want to manage the back end. No servers, no network, no scaling capacity, nothing to manage. Automatic scaling. As your demand increases, you don't have to add more servers, do networking, more storage, none of those. It scales to meet your demand. When the demand goes down, it automatically also scales down without having you worrying about any of those aspects. Just focus on writing the most efficient, the best looking app or application or any other implementations that you have. And then the best part is you don't have to pay any upfront cost for setting up that infrastructure. You only pay for whatever portion that you use. So that's the flexibility that it provides. And that's the promise of any public cloud, for that matter. So there are two types of serverless, at least from our standpoint. One is on the compute side, which is we call front end as a service. And then there's the back end as a service, which is mainly all your databases or any email servers, authentication servers, whatever you have. Those are your back-end system. Front-end systems are mostly your application runtimes, on which the platforms on which you build your apps on, right? Examples are, most of you must be knowing we have App Engine, but we also have Cloud Functions. And then on the back-end side, we have, you can integrate with email servers, SMS, payment systems like PayPal or any of those, and then database stores like BigQuery, Firebase, Cloud ML Engine also, right? And we will see all these a little bit more in detail. So these are different Google components that we have. On the compute side, I told about App Engine, which is platform as a service, where you write your application with, you pick the runtime, whether it's your Python or Node.js or whatever. We have multiple different runtimes available. You don't have to worry about anything up to those points. You just write your application code, choose your runtime, and then submit it. It scales based on however you plan. So it allows you to create your scaling matrix as well, and it can scale up and down based on those parameters. Functions is more like a triggered base. So you just write your code, it's more Lambda, right? So you write your code and it's event driven. That event can be any trigger, like a drop-off file in a storage, or it can be a message that's subscribed through a pub sub, or any other triggers that we can, and we'll see a lot more events like that. Firestore is our backend for Firebase. Firebase is our serverless platform for mobile app development, and Firestore is the backend that supports that. Cloud Data Store, another NoSQL data store, and BigQuery is our NoSQL serverless data warehouse application, on which you can run all your analytics, right? And then there's all this machine learning. We have Cloud ML Engine for those who want to write their custom machine learning models, build those, train them, and then deploy them through Cloud ML Engine. But if you don't want to do that and use some of our pre-built models, but then train them using your data and then deploy them, you can use the AutoML for that. So you don't have to worry about setting up like beefy servers, like using TPUs and all that. It already takes care of that on the back end. You just decide, provision what type of servers you want to use for your model deployment, and it all takes care of it on the back end for you. Data flow, most of you might have heard about Apache Beam, right? So data flow is our managed service for Apache Beam, right? PubSub is our messaging system. That is, again, it can support up to like 1 million plus messages per second, right? And Apogee, and on the front end, we have all these Data Studio for visualization. Firebase, like I said, it's our front end for your app development. And Apogee is API management that we make available to you. And that also is a serverless. But serverless has its pros and cons. So let's look at some of those, right? One, the biggest advantage is it can scale from 0 to planet scale without any intervention, right? But then what's the disadvantage? It also scales from 0 to planet scale. And the disadvantage is that if you are building serverless apps that can scale from 0 to thousands of instances, but your backend database is on-prem or non-serverless, it can crash that, right? If you start sending a lot of requests to that backend server, it cannot support that. So what is some of the recommendations for us is go all in with building out entire pipeline, which is serverless. So from your front end to back end to your visualization or any AI ML that you want to run on it, everything, if you keep it all serverless, everything will work seamless. And we'll see how that can happen. Queuing requests, you can, instead of sending all the queues, you set up priority queues and decide which applications and how many applications can talk to that backend systems. So you can queue your requests, or you can throttle wherever throttling is available, right? But these are some of the recommendations we have. But there's also some other pros and cons. So we saw the pro is that, the con is also that, but it can also crush your wallet. If you do not plan right and build out your serverless environment with proper planning and budgeting, you can easily run. I mean, I'll give you an example. One of the customers uses BigQuery, and just one query they ran, somebody submitted a query, and it processed some hundreds of petabytes of data in just one query, and the cost of that query was $350,000, right? It's because of lack of planning and lack of budgeting. So you can either do is get a planet scale wallet, but that's not possible. So what you can do instead is set up programmatic budgets. We allow you to set budgets on each and every services, and then you also set notifications against those budgets. And the example here is for PubSub, I can specify that I only want to spend $20 per message, right? And I can set saying per topic, and I can set notifications saying if it hits 50%, which is $10, send me a notification, or 80%, 90%, whatever you want. You can set those notifications. Now you are monitoring it, and you can take proactive steps, right? So that's one thing you can do. So let's look at now the 3 blocks that we saw, right? Apps, serverless backend, and then AI/ML. Let's look at them in a little bit in detail. So on the serverless apps, we will have App Engine. We talked about it. It is our fully managed app development platform where you can build your applications either in Java, Python, Go, PHP, Node.js, and it has multiple versions supported across those. So you can build your applications and submit them, run them on App Engine without having to worry about provisioning any servers. You can still set limits saying, I want to run it on this type of server or this group of servers, server types, and scale it to only this. So limit your scaling as well, so you are controlling costs that way, right? So you can set those. Cloud Function is our more like event-driven for microservices type of applications. Again, we have Node.js. Actually, Python is not in beta anymore, and Go is now in beta. So these are the 3 runtimes that are supported on that. And Firebase is the front end for mobile app development, which is you can build out all your mobile applications on that. And Firestore will be, you'll see, is the back end that supports real-time transactions that happen through those mobile applications. So Firebase is our platform, and I'll go a little bit in detail, is for web apps. Like I said, you can build applications on Android or iOS or any other scripting language. It's backed. So the front end is Firebase. Back end is, you'll see, is all supported by Google Cloud. I'm going to skip that here. If you see, what supercharges it is the Firestore, which is the first data store where all the transaction-related information is stored. And then from there, it triggers Cloud Function events that can run analytics on BigQuery. It can call any machine learning API to run some machine learning on any data that you're collecting for that application and give you some insights back. Or it can integrate with some other applications. So let's say one app has to interact with another app. You can send a message through PubSub to another application, and that's how you can integrate with that. Okay? So we saw the front end. The back end is serverless for big data, right? Firestore is one that is one of the most popular ones for mobile applications, like I just showed you. BigQuery is our data warehouse and analytics data warehouse, right? So any large amount of data that you want to process, aggregate, and derive some insights and results for, BigQuery is your no serverless. It supports regular ANSI SQL, so you don't have to learn any new languages. You write your query in SQL, submit the query. No matter how much data you can process, 1 gig of data or 100 gig or 1 petabyte of data, it doesn't matter. You don't have to worry about setting up a data warehouse, none of that. You just land your data into BigQuery, load your data in BigQuery, write your table schema, and start querying against it. You just pay for the amount of data that you query and the amount of data that you store on that BigQuery data warehouse, right? You do not pay for any of the servers, none. You only pay for the data that you query. And then Cloud Data Flow is our ETL for both batch and streaming. So you can either stream data from PubSub and do some ETL and then push it out to another topic on a PubSub, or store it in cloud storage, or you get your batch data loaded up from Google Cloud Store, process it, transform it, and then load it back out to another cloud storage or another database system for that matter, even to BigQuery or any other ones, right? So data flow is your kind of like ETL pipeline builder, right? So we saw Firestore is NoSQL. It synchronizes across clients. So if you have millions of app devices that are constantly sending data, receiving read-write requests to this, it can synchronize against all those different devices. It also has offline support for read-write, and it has consistency, a multi-region high availability, and it has consistency, so it can support transactions. So any e-commerce that you do through your mobile app, it can support that, right? And again, it's pay by the operation. So how many read-write operations you do to that database, you pay based on that and how much storage and bandwidth you need to support that, right? Serverless BigQuery, we saw petabyte scale, terabyte scale, run blazing fast queries, no need to worry about provisioning your large data warehouse environments. Focus more on writing your queries. If you go into the documentation and quick start guides, there are a lot of ways you can even optimize your queries to reduce your cost but get the best result. There are different mechanisms also that you will find in those where you can use partitioning, you can do a lot of clustering and a lot of different methods that you can apply to your data. And it's all columnar table. It's not actual relational database. It's all columnar. So the way it queries the data is very different than that same SQL would go and query a relational database. So it's very different. So the cost is much lower because the amount of data it processes is very low. And you can get a free monthly quota of up to 1 terabyte of data queried and up to 10 gigabytes of data stored. So we have something called BigQuery Sandbox, which you can play with and available to you to use for free, just to get your hands-on experience on BigQuery, right? So let's look at the third building block, which is machine learning, right? We saw the previous talk, which was on IoT and machine learning. So we have serverless for machine learning as well. In this example, you can see that one model uses the regular standard build machine learning model that is just plainly classifying an image that it's a dog. But if I want to identify that this picture is actually of my dog, Miss Potato, I need to train a custom model because the standard readily available models will only classify whether it's a dog or not a dog. It's a binary event. If I want it to do anything further, I need to further train or modify that model or build my new model to do that, to make sure that if a picture of a dog is uploaded and the result comes back, whether it's Miss Potato or not, I need to train it in a different way. That's when our Cloud ML engine comes in play. It's a fully managed platform that allows you to build your models. There's two ways. You can build it on TensorFlow and run it open source anywhere. Or you can build the same model, which is our managed TensorFlow offering. You build the model, train the model, deploy the model using ML engine. You don't have to worry about any of the provisioning of the TensorFlow servers, none of that, right? Configuration, maintenance of those servers, none of that. You just focus on building, training, and deploying your models, right? From there, we also have another step where you have your generic APIs that allows you, we have ML APIs available to you. We have speech, vision, speech to text, natural language processing, all these different machine learning models that we have trained on vast amount of data that we have to provide you readily available models like Translate and all those to start embedding into your applications if they don't meet your requirement. Because, example, I can take the speech-to-text API and use it for regular speech, but if it's a financial industry where they're doing stock trading and they have specific acronyms that they use, probably my model is not trained on that, right? I want to train it on that. I can take the same model and only train it with my data, not having to rewrite the whole model. I just train it on AutoML. So it allows me to use it allows you to use the models that we have built, use it and train it with your data, and then deploy it and serve it. So instead of writing the whole new machine learning algorithm, you are just using the one that we have, just train it with your data, right? It's It simplifies the whole operation. So how do we now bring it all together? You have different steps. One is you want to have an event-based pipeline, which has data processing, and then it has the output that's transferred over, right? The events, you don't have to write any code. We have written enough back-end functional code to automatically poll these different events and provide you a mechanism to trigger a reaction to any of these events occurring. What that allows you is different triggers like data changes. In Firestore, you either read, write, update any record, or in cloud storage, you are dropping a file and you need to trigger something to do the processing of that file. You don't have to write the logic to determine what that trigger is. We already have it. You just tell which trigger you want to use. So you can see there's a whole list of triggers that you can use here, right? You can, from the drop-down menu, you can pick which trigger, where that location of that trigger would be, and start using it, right? Just write the function of what you want to do with that data that is coming in, versus figuring out how to poll that trigger and understand what needs to be done based on that. So here's an example how Cloud Functions is the glue between your trigger and what you need to do, what different processing that can be made available to that. So Cloud Functions you can write your custom script that whatever you need to do with that, or you can interact with any of those, Google Assistant or Dialogflow. Dialogflow is our serverless chatbot application that you can build chatbots on. It's open source. BigQuery, all these different components that you can see, this is speech to text, different APIs that are made available. You can embed those into your functional code, right? So serverless big data processing, cloud data flow, we saw that, right? I talked about it. It's the Apache Beam. It interacts with PubSub, BigQuery, even Kafka. So if you don't want to use PubSub, you can use Kafka. There's a lot of interoperability there. It's, again, pay per second of compute resources that you need. So instead of worrying about, oh, I need to deploy a 100-node Hadoop cluster, maintain it, manage it, none of that. You just write your either Spark code, or you write it in Python, and now there's also going to be support in SQL. So you write your SQL code and submit it to Dataflow. It'll pick the runner underneath as Dataflow as a runner, submit that code, run it for you, and give you the results that you need. So the output of the result goes into wherever you want to save that record. Either you want to save the record into Google Cloud Storage or some other database like BigQuery or Datastore or Bigtable, or you want to invoke any other function, HTTP call to something else, or push that results into PubSub to send it over to some other application, right? So connecting the serverless pieces is our message bus. So PubSub, so if you have two different serverless applications and you want them to interact, or different serverless components you want to interact them with, you use our PubSub. PubSub is our petabyte scale message bus that can process million+ messages at the same time. The way it's made possible is it has a publisher that writes to a topic, and depending on the subscriber, how many, today you have 2 subscribers, the guarantee is each subscriber will at least get the message once. It is asynchronous, it's not synchronous, right? That's the key to remember there, but you can use a lot of different mechanisms. If you read through the documentation, it'll go through, there are different techniques that you can use to process it in a synchronous way. It also has 2 modes available. One is a push mode, where anytime a message is written to a topic, automatically it pushes it down to the subscriber. So the subscriber decides whether they want to receive the messages in push or pull mode, right? So pull mode is you decide when you want to get those messages, either at a fixed time interval or when certain number of messages arrive. If you want to add a new subscriber, automatically you just create a new subscriber and it starts your subscription to that topic. You don't need to do any other further coding. You just have to write one command. That's it. Subscribe to that topic. So how does it all fit in? This is how a typical example for a mobile application would be: a user is writing data to Cloud Firestore. From there, let's say I'm a user saying I'm a new employee that is being added. So it gets, as when I download the mobile app to my company, automatically HR Cloud Function triggers that creates a JSON saying it's a new topic with my user ID and location. It pushes it to PubSub, and then it triggers two different streams. One will say, I need to make a record into the building badge system, and then also so that I can get my new badge for security purposes. And then it also triggers another HTTP request out to a different application that does IT provisioning, whatever my IT privileges and all that needs to happen, right? So without any human intervention, it can get the whole workflow done for you. So one of the biggest advantage we saw is the extensibility of this kind of components, right? Serverless gives you extensibility. You don't have to worry about provisioning. You don't have to worry about interconnectivity. All those are interoperable pieces. So today you have an application that is doing 3 different things, like crop and save an image, resize the image to and save it in another cloud storage, and save the metadata in an index store like Elasticsearch or something. So it's today. Tomorrow, if your requirements change and you want to add some more processing or modify your application to now include, analyze those indexes and attach any new metadata tags that I might have received through user interaction. So let's say you have a picture in your cloud storage and say you identify that picture and tag your cells to it. It takes all that and you can now add another small microservice to it without having to worry about rewriting any of the other code. You just focus on just writing a new function, right? So let's look at a few examples. Hamilton. Hamilton is one of the most popular Broadway show in New York right now. And the wait for the tickets go for few hundreds of dollars, and the wait time for those tickets is like a year sometimes, right? But they have a smart way. They have a lottery system. So very few number of tickets, they reserve it for lottery. I, as a user, can apply for the lottery 2 days before the show time, and the lottery closes at 9 a.m. on the day of the show. So if there's one show, I can only apply once for the lottery between that time window. And then if I win in the lottery, I get notified. So just let's look at that piece. And then it also has the karaoke, the trivia, the ham cam, and even their merchandise store. So we'll see 2 applications or 3 applications here, how they fit in, right? So as a user, when I apply for a lottery, it pushes that data into the Firebase. Through Firebase, it goes to authentication, make sure that I am authenticated user. It sends the notification to Cloud Function, gets it back. Now, when the lottery happens, it's a cron job and an app engine that runs the lottery based on the number of users it has and who are signed up for the lottery. Whoever wins, it notifies the Firebase, and that triggers another function that will then go and notify the user saying, oh, by the way, you've won, right? All this is in a complete serverless app. Same way, they have this app where you can take your selfie and then modify it to meet different frames that they have created for Hamilton. Same thing, it takes the picture, stores it into Google Cloud Storage. It runs a function that will crop and resize that image to fit within that frame, whichever frame you have picked, and then it puts it in another cloud storage, and then also notifies the Firebase where the location of that image is so that it can serve the image that I wanted in the format that I need, right? My selfie. The third one is they have built a merchandise where I can buy Hamilton merchandise. So when I buy it, it triggers two cloud functions. When I say I want to purchase a shirt, it goes and triggers the Magneto API, which is their back-end inventory and operations management to update the inventory, any new purchase orders that they need to make to replenish their inventory and whatever that needs to happen. That workflow gets triggered. The other one is the payment system to take care of all the e-commerce related transaction, right? So that's one. I'll skip through these two. These are another, like this one is in healthcare, how people can use, at Clouder, how people use medical consultation through an app, right? So if I'm having a cold, I don't want to go see a doctor. I would rather just find an online concierge doctor who can help me with like assessing my symptoms and just giving me a recommendation of what needs to be done, right? That's all done through serverless app. The other one is the guestwork.co. That's another retail customer who is using it for recommendation for first-time buyers. So how recommendation engine works in the serverless. Smart parking, we saw this in the previous presentation. Smart parking is one of our customers who is using this for a lot of different things. We will see one of the pipeline is they have installed these IoT sensors at all their parking stops, and it monitors whether the parking spot is occupied or not. And based on that, it communicates, it keeps sending that signal through IoT core via PubSub, and then it triggers a cloud function that updates the screen. Again, it sends a message through cloud function. It triggers another IoT core edge sensor that will update the big giant screen on the parking deck saying how many parking spots are available or not. Is it full, or there are 10 parking spots available, 20 available, depending on how many cars are leaving and coming in, right? That's just one application. It also has other applications like aggregating all that data and sending it to BigQuery, where it can kind of analyze that data and provide you insight on what time of the day, what are your rush hours and busy days, or it even gives you forecasting. By the way, Easter is this weekend, and you will expect certain number of amount of traffic. Be prepared for planning your resources to for parking lot attendance and whatever it is, right? So all those are different IoT examples that are being served by smart parking. So once again, wrapping up, we have different serverless components that we are providing right now, but this is not an exhaustive list. We are constantly adding newer services, newer APIs. I mean, machine learning is one piece where every month there's a new API that's made available out there for people to start using and leveraging into their applications. That's it. So if there are any questions, I'll be here. I'm more than happy to take any questions, but thank you for indulging me and providing this opportunity. Thank you.
If you have questions, please raise your hand.
There's here.
I was curious, what's under the hood on Firebase data, on Firestore database service? What is the database placed under?
It's a version of data store. It's a NoSQL document store. It's a data store.
It's not. I'm talking about Firebase database. It's not real time, but new one. Yeah.
So Firestore.
It's called Firestore. Yes.
Yeah, Firestore.
You're right.
Yeah, maybe.
Yeah, so Firestore, it's a variant of data store, which is our NoSQL database.
Okay. Thank you.
Okay.
Okay, we use BigQuery for our analytics. So we collect some mobile data, and I'm noticed that our cost for query is increased, I think dramatically. Maybe you have suggestion how to reduce cost for BigQuery query.
So there's a lot of different suggestions. Without looking at the query, it's very hard for me to recommend what to do. But if you go into our, BigQuery has a lot of knowledge base that is published on the BigQuery product page. Also, there are a lot of quick start guides. There are a lot of BigQuery best practices. But you can either do, like I said, partitioning. Right now we only support date partitioning, but pretty soon there'll be more support added. You can also do clustering of like similar, like let's say you have a global, you're aggregating data from multiple cities around the world. You can kind of cluster data for same cities together. So sorting and clustering. There's also different techniques that you can use for there's multiple query optimization techniques that we have published on our page that you can look at. But the key is to look at the query. The other way of reducing the query is if multiple people are accessing the same table for deriving the same insight, create a view and share the view with those so that you're not querying the same data again and again from multiple folks. So creating views, there will also be support for materialized views, which will allow you to reduce your cost as well. So there are a lot of different things that you can do there. Any other questions?
Yeah, thank you. First of all, thank you for your interesting presentation. Could you please talk more about the ways Google can help us in authorization and authentication for applications? What solutions can you offer for us as a developers?
For the authorizations piece?
Yeah, some cloud proxies or some other solutions like Beyond Corp or I don't know.
So we have, I mean, there are multiple authorization and authentication components. Like we have service, you can create service accounts for applications and use OAuth against those. On the user authentication, we allow you to embed any third-party authentication services as well, into like for the e-commerce side or any of those. There are multiple different options there.
Are there any options with, which can be related to Active Directory that we have?
So we have a support for AD services. So you can actually now have embed directly sync with AD on-prem or on any other, even AD on a VM. If you're running Active Directory, we have an ability to integrate with those through our application. You can embed, not embed. There's AD configuration management that's just published a couple months ago, and if you go into IAM and single sign-on, there's support for AD on that.
Yeah, perfect. And the second question about memory store, is it now on production or the previous time?
It's still in beta, but very close to coming out to GA.
Ah, okay, thank you.
Yeah. Awesome. Thank you.